Okay, hello everyone. Today I will explain you how to connect this monostable multivibrator. So in this monostable multivibrator we have two BC547 ICs. Okay, these are the transistors required to carry out the function of a monostable multivibrator. Then okay, we have two transistors. I will place this transistor in the diagram. This is Q1 and Q2. Then we have resistors. So we have two resistors of 1 kilo ohm here, another one 1 kilo ohm. We are taking resistance boxes for them, R2 and R4. Okay, R2 1 kilo ohm and R4 1 kilo ohm. Okay, then our RC combination is this R3 and C2. Okay, so for R3 we have 22 kilo ohm resistor. Okay, R3 we are taking 22 kilo ohm resistor, and C2 is of 4.7 nanofarad. C2 we are taking 4.7 nanofarad, and other two capacitors. Okay, other two capacitors, that is C1 and C3. C1 and C3 we are taking 22 nanofarad. Okay, 22 nanofarad. Then there are two diodes. Okay, R5 we are taking 22 kilo ohm. That is R3 and R5 these are same. And there is a standard power supply of 6 volt. So these are the components which are required to join this monostable multivibrator. So one by one we will place the component on the breadboard. Okay, so let us start with the first trigger circuit, that is the right hand side of the diagram. Okay, okay, now it is visible. So in the trigger circuit we have input, that is oscillator is connected over here. Okay, and our C1 is 22 nanofarad. Okay, so let us take 22 nanofarad capacitor. I will place on the breadboard somewhere. Okay. After placing capacitor, we have to connect resistor, that is R1, which is of 1 kilo ohm, and let us ground it. Okay, then we have to put diode. Okay, so we have to be sure that cathode is placed towards the base, okay, of the transistor. Okay, so I am placing this diode over here. Okay, then after placing the diode, let us place this transistor, so that base is connected to the diode. First terminal is collector, then base, then emitter. Okay. So after placing this trigger circuit and transistor, now let us do this parallel feedback network of resistor and capacitor. Okay, feedback network of capacitor and resistor. So we are taking this 22 kilo ohm resistor, okay, R5. Let us place somewhere on the breadboard. Then we have to place this capacitor parallel to the resistor. Okay. Now we have to connect this base of the transistor 1 to this RC pair. Okay, and then another point we have to take it to the collector of the second transistor. Okay, collector of the second. Let us place second transistor over here. Now I have to connect this to the collector of second transistor. So this is RC feedback. Now let us connect power supply. Okay, so we have power supply, okay, connected to the R1. Now for R1 we are taking this resistance box. Two resistance boxes are there. Okay, wait a minute. Okay, let us connect the resistance boxes. Power supply, one terminal is connected over here. Okay, then this power, same power is goes to another resistor. Okay, that is R4. So I have connected R2 and R4. R2 and R4 of 1 kilo ohm. Okay, then we have to connect R3. So R3 is 22 kilo ohm. So let us connect this R3 over here. Okay, R3 over here. So in between this, the R3 is connected to the C2, that is 4.7 nanofarad capacitor. So let us place this capacitor over here, which forms the RC network and which is the heart of monostable multivibrator. Okay, now after connecting this, we have to connect this junction of this resistance and capacitor, that is RC network junction, okay, to the base of Q2. This is I am connecting to the base of Q2. Then we have to connect the collector of Q1. Okay, the collector of Q1 to the point over here. Okay, so now this is Q1 to connect the collector. Collector of Q1, which goes to this point over here. Then we have to connect collector of Q2. Collector of Q1, then we have to connect collector of Q2 to the point over here. Then we have to connect the emitters, short the emitters and make it ground. I shorted the emitters of 2 transistors. Then we have to make it ground. Then we have to connect the frequency supply and CRO to see the output waveforms. So we are connecting this frequency supply of 1 kilohertz, okay, which will trigger the circuit over here. And then make sure that grounded pins are connected together. Okay. Then we have to connect the collectors to see the output. Okay, therefore after joining the complete circuit, okay, we have taken the output across the collectors of the transistor. This is the battery supply, this is the frequency, okay, of 1 kilohertz. Then we have the output across the CRO. So from the CRO we can see that the pulse width during which the transistor is of 0.4 centimeter and time base is 0.2 millisecond. So let us calculate the pulse width, theoretical one and experimental. Theoretical TP and experimental TP. Experimental TP. Okay, formula is 0.7 RC. Okay, so in this case 0.7 into R, 22 kilo ohm. Okay, and C is 0.047 microfarad 10 raised to minus 6. This is experimental TP. We know that this is 0.4 centimeter into time base 0.2 millisecond. So this is 0.08 millisecond and this is 0.7 into 22 to 0.047 into 10 raised to minus 3. So after calculating this, we'll come to know that this is approximately equals to 0.07 millisecond. So our theoretical value matches with the experimental value. Now this case is for capacitor value of 0.047 microfarad. Now let us switch the capacitor. C equals to 0.1 microfarad, and again compare TP, that is theoretical, and experimental one. Now let us change the capacitor. Previous capacitor is of 0.047 microfarad. Now I am connecting 104, that is 0.1 microfarad. And after changing the capacitor, let us see the waveform. Now this is the waveform for the capacitor of 0.1 microfarad. We can see that the pulse width is 2.2 centimeter and time base is 0.5 millisecond. Now let us calculate. Now the theoretical calculation, we know that TP equals to 0.7 RC, 0.7 into R is up our 22 kilo ohm. Now C has changed, that is 0.1 into 10 raised to minus 6. So this is 0.7, 22 into 0.1 into 10 raised to minus 3. And after calculating this, come to know that 1.5 millisecond is our TP, and experimental one is TP equals to, this is 2.2 centimeter multiplied by time base 0.5 millisecond, and this will come out to be 1.1 millisecond. So our value is near one to each other. Okay, I hope you understand the monostable multivibrator experiment. Now I will tell you now let us see what happens in this monostable multivibrator. Okay, so in monostable multivibrator there are two states, that is stable state and quasi-stable state. Okay, so from the beginning, what happens, the resistor R3 is connected to the power supply VCC. Okay, so through this power supply R3 makes Q2 on, and in this situation Q1 is off, Q2 is on and Q1 is off. Now this is the one stable state of the monostable multivibrator. Now due to Q1 is off, so capacitor C2 charges to VCC. Capacitor C2 charges to VCC. Now what happens in a quasi-stable state? In a quasi-stable state, this previous state, that is Q1 off and Q2 on, okay, if we apply a trigger to the Q1, okay, it will make Q1 on, and due to Q1 on, capacitor discharges, C2 discharges, no voltage on capacitor, so it will make Q2 off. and this is the quasi-stable state of a monostable multivibrator. And same this Q2 of the voltage across the collector over here. Okay, this is applied to the base of Q1 and it will saturate this Q1. Okay, now the process repeats. After applying the trigger, again there is a shift in the on-off cycle of the transistors. Okay, I hope you understand this monostable multivibrator.